For today's video, we are going to talk about what is hyperbola and we are going to explain everything in details. So when we say hyperbola, it is a locus of points which moves so that the difference of its distances from two fixed points called foci is equal to the length of the transverse axis 2a. As you can see in the given figure, this point is what we call the center. Center is always h and k. And this line is what we call the transverse axis. It is a line that connects the vertices. The length of the transverse axis is 2a. Half of the transverse axis is called semi-transverse. And the length of the semi-transverse is a. That is the distance from the center and one of the vertices. And this line is what we call the conjugate axis. Conjugate axis is a line that connects the co-vertices. The length of the conjugate axis is 2b. Half of the conjugate axis is called semi-conjugate, and the length of semi-conjugate is b. And that is the distance from center to one of the co-vertices. And this point is what we call the foci. Foci is always collinear with the vertices and center. And the distance from center to one of the foci is C. This line is what we call the latus rectum. And this line is what we call the asymptotes of the hyperbola. And these are the different parts of hyperbola that you need to remember. Now let us talk about the different forms of equation of hyperbola. The standard form of equation of the hyperbola with the center at h and k. If our hyperbola is horizontally oriented, we are going to use the formula quantity x minus h squared all over a squared minus quantity y minus k squared all over b squared equals to 1. And if our hyperbola is vertically oriented, we are going to use the formula quantity y minus k squared all over a squared minus quantity x minus h squared all over b squared equals to 1. If our hyperbola is horizontally oriented, the coordinates of our vertices is at h plus a and k and h minus a and k. And the coordinates of our co-vertices, that is h and k plus b and h and k minus b. While our foci is h plus c and k and h minus c and k. And the equation of the line of directrices, that is x equals h plus or minus a squared over c. And the asymptotes, that is y minus k equals plus or minus b over a times quantity x minus h, while the length of the latus rectum, that is 2b squared over a. And if our hyperbola is vertically oriented, the coordinates of our vertices, that is h and k plus a and h and k minus a, while our co-vertices, that is h plus b and k and h minus b and k. And the coordinates of our foci, that is h and k plus c and h and k minus c. And the equation of our directrices, that is y equals k plus or minus a squared over c. And the asymptotes of our hyperbola, that is y minus k equals plus or minus b over a times quantity x minus h. And the length of the latus rectum, that is 2b squared over a. And these are the basic concepts that you need to remember in order for us to understand what is hyperbola. So let's start and let's have an example. On the given set of example, we are going to identify the coordinates of the vertices, co-vertices, foci, the equation of the directrices, the asymptotes of the hyperbola, and the length of the latus rectum. On the first example, we have quantity x minus 2 squared all over 9 minus quantity y plus 1 squared all over 16 equals to 1. Since the given equation is written in the form of quantity x minus h squared all over a squared minus quantity y minus k squared all over b squared equals to 1, we can say that the orientation of our hyperbola is horizontally oriented. So let us determine the center of our hyperbola, that is h and k. So let us have the value of h, that is positive 2, that is the opposite sign of negative 2, and the value of k, that is negative 1, that is the opposite sign of positive 1. So this will be our center. And then let us have the value of a squared, that is 9, b squared, that is 16. To find the value of a, let us have the square root of 9, and that is 3. To find the value of b, let us have the square root of 16, and that is 4. A, that is the length of semi-transverse, and b is the length of semi-conjugate. To find the length of transverse axis, let us have 2a. Let us have 2 times the value of a, that is 3. 2 multiplied by 3, that is 6. So this will be the length of our transverse axis. And to find the length of our conjugate axis, let us have 2b. 2 multiplied by b, that is 4. 2 times 4 is 8. And this will be the length of our conjugate axis. So let us determine the coordinates of our vertices. So let us have vertices. Since our hyperbola is horizontally oriented, we are going to have h plus a and k, and then h minus a and k. So let us have the value of h, that is 2, plus a, that is 3, and then negative 1. And then on the other side, we have 2 minus 3, and then negative 1. 2 plus 3, that is 5, and negative 1. And then 2 minus 3 is negative 1 and negative 1. So this will be the coordinates of our vertices. And to find the coordinates of our co-vertices, let us have co-vertices. That is h and k plus b, and h and k minus b. So we have the value of h, which is 2, and k is negative 1, plus b, that is 4. And then we have 2, negative 1 minus 4. So let us have 2, negative 1 plus 4, that is 3. And then we have 2, and negative 1 minus 4 is negative 5. So this will be the coordinates of our co-vertices. And to find the coordinates of our foci, let us have h plus c and k, and then h minus c and k. So to find the value of c, we are going to use the formula c squared equals a squared plus b squared. The value of a squared, that is 9, and the value of b squared, that is 16. 9 plus 16, that is 25. So let us square both sides to find the value of c. So c, that is the square root of 25, and that is 5. So this will be the value of our c. So let us have the value of h, that is 2, plus c, that is 5, and then k, that is negative 1. On the other side, we have 2 minus 5 and negative 1. 2 plus 5, that is 7, and then we have negative 1. On the other side, 2 minus 5 is negative 3 and negative 1. So this will be the coordinates of our foci. And then, let us find the equation of our directrices. Since our hyperbola is horizontally oriented, we are going to use x equals h plus or minus a squared over c. So let us have the value of h, that is 2, plus or minus a squared, that is 9. Then the value of c, that is 5. So if we are going to separate this one, we are going to have x equals 2 plus 9 over 5. On the other side, we have x equals 2 minus 9 over 5. So let us simplify x, and then let us have 5 on the denominator. 5 multiplied by 2, that is 10, plus 9. It will give us 19 over 5. And if you are going to divide this one, so we have x equals 3 and 4 over 5. On the other side, we have x equals 5 on the denominator. 5 multiplied by 2, that is 10, minus 9, and that is 1 over 5. So this will be the equations of our directrices. And to find the asymptotes of the hyperbola, let us have another sheet of paper. Since our hyperbola is horizontally oriented, we are going to use y minus k equals positive or negative b over a times quantity x minus h, where the value of k is negative 1, the value of h is positive 2, the value of b, that is 4, and the value of a is 3. So let us have y minus the value of k, that is negative 1, equals positive or negative b, that is 4, over a, that is 3, times quantity x minus the value of h, that is positive 2. So let us simplify. Let us have y plus 1, that is negative times negative is positive, and then we have positive or negative 4 over 3 times x minus 2. So if we are going to separate this one, we are going to have y plus 1 equals 4 over 3 times quantity x minus 2. On the other side, we have y plus 1 equals negative 4 over 3 times quantity x minus 2. So let's simplify. Let us multiply 3 times y plus 1, that is 3y plus 3 equals 4 times x is 4x. And 4 multiplied by negative 2, that is negative 8. So let us move 4x on the other side of equation, and let us move 3 on the other side of equation. It will give us negative 4x plus 3y equals negative 8 minus 3. So let us have negative 4x plus 3y equals negative 8 minus 3 is negative 11. And let us multiply the whole equation by negative 1. It will give us 4x minus 3y equals 11. While on the other side, let us have 3 multiplied by y plus 1, that is 3y plus 3 equals negative 4 times x is negative 4x. Negative 4 multiplied by negative 2 is positive 8. Let us move negative 4x on the other side of equation, and let us move 3 on the side of negative 4x plus 8. It will give us 4x plus 3y equals 8 minus 3. So this will be 4x plus 3y equals 5. So this will be the asymptotes of our hyperbola. And to find the length of our latus rectum, let us have length of the latus rectum is equal to 2b squared over a. We have 2 times the value of b squared, that is 16, over a, that is 3. 2 multiplied by 16, that is 32 over 3. And if you are going to divide this one, we are going to have 10 and 2 over 3. And this will be our answer. On example number 2, we have y squared over 144 minus quantity x plus 3 squared all over 25 equals to 1. So this time, the given equation is written in the form of y minus k squared all over a squared minus quantity x minus h squared all over b squared equals to 1. We can say that the orientation of our hyperbola is vertically oriented. So let us determine the center of our hyperbola, that is h and k. So let us have the value of h, that is negative 3, that is the opposite sign of positive 3. And since we don't have k, we are going to have 0. So this will be the center of our hyperbola. So let us have the value of a squared, that is 144, b squared, that is 25. To find the value of a, let us have the square root of 144, and that is 12. To find the value of b, we have the square root of 25, and that is 5. A, that is the length of semi-transverse, and b, that is the length of semi-conjugate. So to find the length of transverse axis, let us have 2a, 2 multiplied by the value of a, that is 12, and that is 24. So this will be the length of our transverse axis. And to find the length of the conjugate axis, let us have 2b, 2 multiplied by the value of b, that is 5, and that is 10. So this will be the length of our conjugate axis. So let us determine the coordinates of our vertices. Since our hyperbola is vertically oriented, we are going to have h and k plus a and h and k minus a. So let us have the value of h, that is negative 3, while the value of k, that is 0, plus the value of a, that is 12. On the other side, we have negative 3 and 0 minus 12. So the coordinates of our vertices, that is negative 3 and 12, and negative 3 and negative 12. And to find the coordinates of our co-vertices, let us have h plus b and k, and then h minus b and k. So the value of h, that is negative 3, plus the value of b, that is 5, and the value of k is 0. On the other side, we have negative 3 minus 5 and 0. Negative 3 plus 5 is 2 and then 0. And negative 3 minus 5 is negative 8 and 0. So this will be the coordinates of our co-vertices. And to determine the coordinates of our foci, let us have foci. And since the orientation of our hyperbola is vertically oriented, we are going to have h and k plus c, and then h and k minus c. To find the value of c, let us use the formula c squared equals a squared plus b squared. The value of a squared, that is 144, plus b squared, that is 25. 144 plus 25, that is 169. So to find the value of c, let us square both sides. The square root of 169, that is 13. So this will be the value of c. So let us have the value of h, that is negative 3, and then k, that is 0, plus the value of c is 13, and then we have negative 3, and then 0 minus 13. So let us have negative 3 and 13, and then negative 3 and negative 13. So this will be the coordinates of our foci. And to find the equation of our directrices, since our hyperbola is vertically oriented, we are going to use y equals k plus or minus a squared over c. So let us have the value of k, that is 0, plus or minus a squared, that is 144, over the value of c, that is 13. If we are going to separate this one, we are going to have y equals 144 over 13 and y equals negative 144 over 13. And if we are going to divide, we are going to have y equals 11 and 1 over 13. On the other side, we have y equals negative 11 and 1 over 13. So this will be the equation of our directrices. And to find the asymptotes of our hyperbola, since our hyperbola is vertically oriented, let us use the formula y minus k equals positive or negative b over a times quantity x minus h, where the value of k is 0, the value of h is negative 3, the value of a is 12, while the value of b is 5. So let us have y minus the value of k, that is 0, equals positive or negative the value of b, that is 5, over the value of a, that is 12, times quantity x minus the quantity negative 3. And to simplify, let us have y equals positive or negative 5 over 12 times quantity x plus 3. Negative times negative is positive. And then, if we are going to separate this one, let us have y equals 5 over 12 times quantity x plus 3. On the other side, we have y equals negative 5 over 12 times quantity x plus 3. So let us have 12 multiplied by y, that is 12y, and then 5 times x is 5x, and then 5 multiplied by 3, that is 15. So let us move 15 on the other side of equation, and let us move positive 12y on the side of 5x plus 15. It will give us negative 15 equals 5x minus 12y. If we are going to write this one in standard form, we have 5x minus 12y equals negative 15. While on the other side, we have 12 times y is 12y equals negative 5 times x is negative 5x. Negative 5 times 3 is negative 15. Let us simply move negative 15 or negative 5x on the side of 12y. It will give us 5x plus 12y equals negative 15. So this will be the asymptotes of our hyperbola. And to find the length of our latus rectum, let us have length of the latus rectum equals 2b squared over a. So let us have 2 times the value of b, that is 5, and 5 squared, that is 25, all over the value of a, that is 12. 2 multiplied by 25, that is 50 over 12. And if we are going to divide this one, we are going to have 4 and 2 over 12, or you can write as 4 and 1 over 6. And this will be our answer. On our last example, we have 9x squared minus 4y squared minus 18x minus 16y minus 43 equals to 0. Since the given equation is written in general form, let us convert this one into standard form in order for us to determine the coordinates of the vertices, covertices, foci, the equation of directrices, the asymptotes, and the length of the latus rectum. So let us move negative 43 on the side of 0, and then let us have 9x squared minus 18x minus 4y squared minus 16y equals 43. And then let us factor this one. Let us have 9, and then we have x squared, negative 18x divided by 9, that is negative 2x. And then we have negative, and then let us have 4. Then we have y squared, negative 16y divided by negative 4, that is positive 4y equals 43. And let us perform a completing the square. Let us have 9 times quantity x squared minus 2x plus blank minus 4 times quantity y squared plus 4y plus blank equals 43 plus blank plus blank. So what must be the number to make this expression as a perfect square trinomial? Let us have negative 2 divided by 2 is negative 1. Negative 1 multiplied by itself, that is 1. So we are going to add 1. And since we have 9, we are going to multiply 1 by 9. And then 4 divided by 2, that is 2. 2 multiplied by itself, that is 4. So we are going to have 4. And since we have negative 4, we are going to multiply this one by negative 4. So let us have 9 times quantity, the square root of x squared, that is x. Sign of the middle term is negative. And then the square root of 1, that is 1. And then we have a square. Minus 4 times quantity, the square root of y squared is y. Sign of the middle term is positive. Square root of 4, that is 2. And then we have a square. 9 multiplied by 1 is 9. Negative 4 times 4 is negative 16. 43 plus 9 is 52. 52 minus 16 is 36. And then, to write this one into standard form, let us divide the whole equation by 36. The greatest common factor between 9 and 36 is 9. 9 becomes 1, 36 becomes 4. The greatest common factor between 4 and 36 is 4, so 4 becomes 1 and 36 becomes 9. 36 divided by 36 is 1. So we are going to have x minus 1 squared all over 4 minus quantity y plus 2 squared all over 9 equals 1. And this equation is written in the form of x minus h squared all over a squared minus quantity y minus k squared all over b squared equals to 1. It will give us the idea that our hyperbola is horizontally oriented. So let us determine the center of our hyperbola, that is h and k. So the value of h, that is 1, that is the opposite sign of negative 1. The value of k, that is negative 2, that is the opposite sign of positive 2. So this will be our center. And then the value of a square, that is 4. The value of b square is 9. To find the value of a, let us have the square root of 4, and that is 2. To find the value of b, let us have the square root of 9, and that is 3. So a, that is the semi-transverse, and b is the semi-conjugate. To find the distance of transverse axis, let us have 2a. 2 multiplied by the value of a, that is 2. 2 times 2 is 4. So this will be the length of our transverse axis. And to find the length of our conjugate axis, let us have 2b. 2 multiplied by the value of b, that is 3, and that is 6. And this will be the length of our conjugate axis. So let us determine the vertices of our hyperbola. Since our hyperbola is horizontally oriented, let us have h plus a and k, and then h minus a and k. So let us have the value of h, that is 1, plus a, that is 2, and k is negative 2, while on the other side we have 1 minus 2 and negative 2. So let us have 1 plus 2, that is 3, and negative 2, and then 1 minus 2 is negative 1 and negative 2. So this will be the coordinates of our vertices. And then, to find the coordinates of our co-vertices, let us have h and k plus b, and then h and k minus b. Let us have h, that is 1, and k is negative 2, plus b, that is 3. And then we have 1 and negative 2 minus 3. So let us have 1, negative 2 plus 3, that is 1. And then 1, negative 2 minus 3 is negative 5. So this will be the coordinates of our co-vertices. And to determine the coordinates of our foci, since our hyperbola is horizontally oriented, we are going to have h plus c and k, and then h minus c and k. And to find the value of c, we are going to use the formula c squared equals a squared plus b squared. A squared, that is 4, b squared, that is 9, 4 plus 9, that is 13. So let us square both sides. So c is equal to square root of 13. So let us have h, that is 1, plus square root of 13, and then the value of k, that is negative 2, and then we have 1 minus square root of 13 and negative 2. So this will be the coordinates of our foci. And to determine the equation of our directrices, since our hyperbola is horizontally oriented, we are going to use the formula x equals h plus or minus a squared over c. So let us have h, that is 1, plus or minus a squared, that is 4, and the value of c, that is square root of 13. So let us simplify. Let us have 1 plus or minus, let us rationalize this one. By multiplying the numerator and denominator by square root of 13, it will give us 4 square root of 13 over 13. That is 13 times 13 is 169, and the square root of 169 is 13. And if you are going to separate this one, we are going to have x equals 1 plus 4 square root of 13 over 13. On the other side, x equals 1 minus 4 square root of 13 over 13. So let us have 13 on the denominator, and then 13 times 1 is 13 plus 4 square root of 13. So this will be the equation of our directrices. On the other one, we have x equals 13 on the denominator, that is 13 minus 4 square root of 13. And then, to find the asymptotes of our hyperbola, since our hyperbola is horizontally oriented, we are going to use the formula y minus k equals positive and negative b over a times quantity x minus h. While the value of k is negative 2, the value of h, that is 1, the value of a, that is 2, and the value of b, that is 3. So let us have y minus k, that is negative 2, plus or minus b, that is 3 over 2 times quantity x minus 1. So let us simplify. We have y plus 2, that is negative times negative, equals positive and negative 3 over 2 times quantity x minus 1. So if we are going to separate this one, we are going to have y plus 2 equals 3 over 2 times quantity x minus 1. On the other side, we have y plus 2 equals negative 3 over 2 times quantity x minus 1. So let us have 2 multiplied by y plus 2, that is 2y plus 4 equals 3 times x is 3x. 3 multiplied by negative 1 is negative 3. So let us move negative 3 on the other side of equation, and let us move 2y on the side of 3x minus 3. So let us have 4 plus 3 equals 3x minus 2y. So let us have 3x minus 2y equals 4 plus 3, that is 7. On the other side, we have y plus 2 times 2, that is 2y plus 4 equals negative 3 times x is negative 3x, and then negative 3 times negative 1 is positive 3. So let us move negative 3x on the other side of equation, and let us move 4 on the side of negative 3x plus 3. It will give us 3x plus 2y equals 3 minus 4. So let us simplify. 3x plus 2y equals 3 minus 4 is negative 1. So this will be the asymptotes of our hyperbola. And to find the length of our latus rectum, let us have the length of the latus rectum equals 2b squared over a. So we have 2, and the value of b squared, that is 9, and then the value of a, that is 2. So we can cancel this one. So the length of our latus rectum, that is 9, and this will be our answer. So I hope you've learned from this video. Thank you so much for watching, and God bless us all.